So very good afternoon, good morning students. So today what you're going to see is controller and function features. Okay, already we've seen that uh, we have three subsystems, instrumentation subsystems, control systems and the operator subsystems. So already we've seen the interface subsystems and the operator subsystems. So now we are going to see the control and functional features. That deals about the controller subsystem. So if you come into basic strategies for the implementation of automation schemes, we have three categories: uh, instrumentation systems, control systems, and human interface systems. Okay, so these three systems will interface to the process and transfers the data, and process the data, and we can control the process. Therefore, this is three subsystems. Okay, so now we are going to see only the control subsystems. So control systems is we having different types of control systems. One is open loop and closed loop control systems or feedback control systems. Okay. So generally you know what will be open loop, what will be closed loop. Okay. If you're not having any feedback system, that is called as a open loop control. If you're having a feedback system, that is called as a closed loop control system. Okay. So we are going to see only the control systems and the architecture and what are types of control systems and what are the possibilities of the control system types in the DCS, that means in the industrial process automation. If we coming to open loop and closed loop control, as I already said, okay, we have the controller and the controller feeds a signal to the process, and if any disturbance is there, we can able to find out in the response. Okay. So what happens here? We're not having any feedback system. So what happens? So we cannot able to control the process as accurately. Coming to closed loop control, yes, we have the controller, the same process. Okay. And what happens? We're giving the signal, the input signal from the computer is fed to the process and getting the response and getting the feedback from the response and taking the output as a feedback and going to the compare the set value, and if any error is there, the error will be rectified by the controller here, and coming here it's a controlled input. Okay, it's a control input to the process, and finally what happens, we get the defined output. Okay. So what happens here? Here we are not having the error director, so we can what are the input giving feeding from the controller is the giving to the process is the control input, but it is not we cannot able to say that's accurate. But here what happens? Finding the errors and rectifying the errors and the rectified errors and the rectified inputs are transferred to the process to get the defined output. Okay. So actually there are two types of controls of that: discrete control process and continuous control process. If we take a discrete control process, it's employed for processes involving only discrete inputs and discrete outputs. That means what happens if we take a on off. Okay, so we have as a relay, we need, as you know the relay. It's electromechanical relay. Electromechanical relay. What happens? It switch on or off. Okay, so what happens? It's a relay controlled. For example, I'm taking it's a relay controlled device. Okay, so it may be switch on or off the process. Okay, we comparing the input or without comparing the input. Okay. So what happens? It's a discrete process. That means on-off command only possible here. And the on-off command are issued to the process from the controller. So if you take a controller, the controller gives signal on or off. It will not be continuous signal. It will be discrete signal. Okay. Whether it should be on or off to switch on or off the process or to switch on off the systems. Okay. So actually, the discrete control can be classified into open loop control and sequential control with interlock. So you can see the sequential control interlock in the forthcoming slides. What will be open loop control? It's we having the breaker. If you take a water automation system, what we've seen already in the class, we having the breaker to switch on or off the heater. We having the valve to switch on or off the water heater. Okay. So we having a level sensor, we having the temperature sensor. The temperature sensor to monitor the process of the water heater, and the temperature is going high means we have to switch off the breaker. And what happens? The breaker will cuts the circuit to give the energy. Cuts the energy. What's giving on the heater to heat the water. Okay. So if you come into this side, what happens? Same thing. Okay. If the water level is in the water level in the heater is going on, I means we have to switch off the valve. If it comes beyond that level, means to switch on the valve. Okay. So what happens if you take the water heater automation process? Okay. If you have it's open loop or closed loop, it's open loop only. What happens? The power to process giving breaker. What happens once the power is given? What happens? Switch on breaker switched on and gives the energy to the water heater to heat the water in the water heater. Okay. So this is and you can able to monitor the temperature. Okay, if you come into valve, what happens? You know, you know the level of the water in the heater, and what if the level of water comes down, we want to switch on the valve. Okay, if the level of water comes beyond the level, it wants to switch off the valve. Okay, only switch on or switch off. That means discrete. Okay, means it gives the discrete inputs and outputs on or off command. It is not a continuous command. Okay, with it gives signal either on or off as like a electromechanical relay. If we come into next slide, next type is discrete control, sequential control with interlocks. Here what happens, it's a simultaneous process. Okay, the simultaneous process, what happens, it goes on or off. Okay, then if you come into here, it's a continuous process. That means sequential process. Okay, it executes step by step. What's the drawback for open loop category is it does not consider the, for example, doesn't consider the availability sufficient of water in the tank before switching on the power. It want to consider, for example, if you take generally, the water level have to be filled in the water heater, then only the water heater have to switch it off. If you come into open loop, it's in simultaneous process. What happens? The temperature sensor will not find out whether water level in the tree is in the correct level or not. Okay, so if the temperature comes down, it switch on the breaker to give the energy to the heater, and it is going to be the water in the water heater. Similarly, coming to this side valve, it will not check whether temperature is, what about the temperature, what about the level of the water. Okay, if the level of the water is not there, what happens, the heating oil is going to heat it, it goes to problem. So what happens, it is a simultaneous process. This process will not check this thing, this process will not check thing. Okay, so it is individual process, it will goes with on off or off circuits. If you come into valve, yes, if the water level is there, yes, it's on or off. Okay, but if you come into this side, the discrete control, what I said is the drawback of open loop control category. It does not consider the availability of the water in the tank before switching on the power. That's a problem. Okay. So if the temperature in the water comes down, what happens? The heater will not check whether the sufficient water level is there in the tank or not. Okay. So it's whether the water level is there or not. Okay. You switch on the heater to heat the heating coil in the tank, and water level, the water temperature of the water is going to increase in the water heater. Okay. That's a drawback of open loop category. Okay. If this not taken care, what happens? Sometimes it's going to be damaged, or sometimes what happens, the short circuit is going to be happen, or it is going to be spoiled. Okay. So that is a problem for the discrete control open loop. If we come into sequential control, this is a problem overcome by sequential control with interlocks. That means interlock. Interlock means we having the condition. What condition means? If the level of the water in the tank is up to the limit, then only the water heater in the tank is going to be heated. Heater in the water tank is going to be heated. Even though the temperature in the water tank comes down, okay, what happens if we propose a sequential control interlock? What they will think, what they check it, whether the water is up to the level or not. If the water is not up to that level, even though the temperature comes down, it will not give a signal to switch on the heater. Okay. So that's a problem. Okay. That's advantage of the discrete control. So what saying is sequential control with interlocks is necessary to allow sufficient time to fill the water in tank. After that only it is going to be eat the water level, eat the water content in the water heater. Okay. That's the thing he's saying. It ensures in each step the desired intermediate conditions and interlocks are satisfied before executing each step. So if we are having a sequential steps, okay. So if it goes to next step, it will check that whether the previous steps are executed properly or not. If it not executed properly, the next step will not be executed. That's the thing we are saying discrete controller. If you go into previous side, open loop controller, it's a simultaneous process. Okay, it will not check whether the process happened or not. Okay, so it starts to work as per the command what we feed it, but it is not a sequential process. It is a simultaneous process. Okay, so as I already said, if the water in the heater is started to heat, but the water is not there, then what happens? Heating coil is going to be damaged. So here what happens is control input. The control is the process there, giving input process. Input process taken care by sequentially can check the interlocks. If the interlocks is okay, that means previous steps, each and every steps are executed properly, then when it goes to the next process. Okay, then we can get the defined response. This discrete control is used in the bottling automation, sequential process automation. For example, we take the paper industry, cement industry, water, maybe the process industries. Step by step, only execute the process. We are not executing any parallel process to get the defined outcome. Okay, going to bottling automation, what happens? First, it checks the it checks the it checks the water bottle whether it's any crack is there or not. Okay. Second stage is it's any unwanted foreign substance or not. After that, that bottle will be cleaned by the pressurized air and water. Then fourth stage is essence will be poured in the water bottle, and if you come into fifth stage, the what are the essence, what are the contents filled in the bottle, it will be checked by the image it will go for inspection with the image processing technique. After that, the cap is going to be filled. Okay, these are sequential process. For each and every process, we have we have a single controller, but each and every process is executed with respect to the controller. The controller checks whether this process happened properly or not. If this process not happened properly or not, if the process not happened, the controller will not execute the other process, next process. Okay. So since it is not a continuous process, it's a discrete process. But what happens? We are having sequential control, step-by-step control is there. Okay. Sequential control means sequential process control. Sequential process means each and every process checked properly, and if any process in the system is not happened properly, the sequential control will not allow us to execute the remaining process. Okay, we come into lift elevators. Okay, we're going to take lift elevators. If we enter the lift, we have to press one means. After pressing one, okay, what happens? The door have to be closed, and third, then the lift is going to be travel to the first floor. Then next process, once it's traveled, it shows that your target is reached. Again, the door is opened. Okay, again you have to come outside. If you're not coming outside, if you're coming outside or not, okay, not a problem. The door is closed. If some other guys are passing on the door, it takes some more time to wait for the closing the doors. Okay, so that means sequential control. What I am saying, the discrete control, whether on or off, but what it's executed with respect to sequential control to the interlocks. Okay, you can able to understand with respect to this slide. So sequence control will be interlocks of water heater. We are having the water heater automation systems. You know, this is a on-off breaker water heater. This breaker is adapted to heat the water in the water heater. Coming to next this closed loop system indicates the valve, on or off valve. Okay, valve controller. This is a power breaker. That means to switch on or in this circuit, this breaker to switch on or switch off the water heater. The heater in the heating coil in the water heater. This valve debuted to switch on to shut down or open the valve in the water heater. Okay. So what happens here? You know, once the water in the water, once the water level in the water is reached, okay, it gives a signal. You can able to find out on off valve is there. Once the valve is on, it allows the water in the water heater tanker. Okay, once the water in tank reaches target level, it gives signal to the valve. Once it reaches the target level, it switch off the valve. Okay, switch off the valve, and what happens? The signal will be cut off here, and the water will be the water level in the water is going to be reached. Okay. Similarly, water output coming as taken as an input for the input means it's taken as a signal. It's taken as an input for the on-off breaker. Okay. Once the water level in the water heater reaches to a certain limit, then what happens? If the power to water is ready, okay. So once it reaches a certain level, then it gives signal to the breaker, and breaker, that means it gives signal to the power, and the power is energized. Power is energized the breakers, and the breaker is on, means it gives a signal to heating coil in the water heater, and the water heater starts to heat. Okay. Once the temperature reached means, okay, what happens? It gives signal to the breaker. It's a controller. Okay, the controller find out whether the temperature reaches properly or not. Once the temperature reaches properly, okay, the power to the water heater is cut off, and parallel the water heating coil in the water heater is cut off. So this is the entire process of the sequential control. So here what happens? We have pretty interlock. What interlock is there? What interlock means? Once the water level in the water heater is reached to a certain limit, then only the power to the breaker is going to be energized, and heating coil is going to be energized, and the water is going to be heated. Okay, that means the water in the heater is going to be heated. Okay, so if the level of water is not to a certain level, what happens? Even if not certain level, even though it gives signal to on a breaker, the breaker will not allow us will not give a signal, to the heating oil to heat the water in the water heater. Okay, so this is a process of this discrete signal. This is a discrete signal. Discrete signal means we are having a on-off controller. Okay, so on-off controller is that two controllers, on-off discrete controller, on-off controllers. So just a minute. On-off controller. So on-off controller is there. On-off controller is a discrete controller. It taking care to switch on or off the water heater. Here to switch on or off the level control in the water heater. Okay, so what happens? Takes a signal from the water level, that means one from the water content, what's the level of the water in the heater content, and goes into the breaker, means breaker. Once the sequence is executed properly, the second sequence is going to be started. Okay. First sequence is not going to be executed, there will be interlock. I mean there's interlock. Okay. If interlock is not executed properly, first sequence is not executed properly, there will be interlock, and it not allows the second process to execute in the system. Okay. So that's the thing we are going to say, that discrete signal. Okay, discrete signal. First is open loop and closed loop system. With the open loop system, without any feedback, we come into discrete signal with continuous closed loop system. Here we are having a sequential control with interlocks. So on-off controller, but sequential control with interlocks. We come into the second thing, continuous control. So last was so far we are saying is discrete controller. Now we are going to see the continuous controller with continuous process. Here what happens? We are going to take analog inputs and analog outputs for the instrumentation devices. Okay, the same thing here, discrete signal. Here what happens? Here continuous signal, analog input and analog outputs. If you come in here also, we categorize the continuous control into open loop control and closed loop control. Okay. Open loop control and closed loop control, and it's a continuous process. It is not a discrete process, it's a continuous process. What's a continuous process? For example, you can able to see the variable voltage source increases or decreases the power flow to the ET element proportional to the input. That, for example, if you take discrete signal, we are going for on or off. If we come in on off, if we take this is controller. If we go into discrete controller, that's on or off. If we come into continuous controller, we have to vary the voltage from 0 to 5 volt, and depending upon the voltage, we can control the water heater. Okay, for example, if we take the 0 to 2 voltage, switch on the water heater, whether it's 0 or 1 or 2. Okay, so if it starts from 2 to 5, 2.5, 3, 4, 4.5, whatever, it switch off the water heater. Okay, so the process is the same, but here what happens, on or off controller is proposed in discrete process, but when coming to control process, having the limits, that's a continuous process. For example, 0 to 5 volts. So we have 0 to 5 volt indicates to switch on or switch off the process. In that 0 to 5 volt, we say that 0 to 3 volt, we can categorize like that. 0 to 2.5 volt taken care by the to switch on the water heater, then 2.6 to 5 volt it taken care to switch off the water heater. As like that we can categorize. For example, I am saying, okay, we have certain limits. So that's a continuous process. So we have certain limits to control the process. Okay, with respect to voltage, varying the voltage in the signal. Okay. So if you take open loop controller here, open loop continuous control for the level and temperature of water heater I am saying here. Okay. The same process, the same example what I am taking here is water level automation system, water heater automation system. Instead of the discrete controller, we are having a on-off controller. You are having the continuous controller. The remaining parts are same. Okay. So this is debited for the continuous control water to water heater, continuous control voltage to water heater. That means we are having a voltage source. There we are having a relay base of solid state devices to switch on or switch off the device. Here also the same thing to switch on or switch off the heater. Okay. But the input signal is variable voltage source. Okay. There discrete controller is a variable voltage source. Okay. Here once the variable voltage source increases or decreases the power flow, it element proportional to input. Okay. Once if it increases, what happens? What I said 0 to 2.5, it indicates to switch on the water heater. Again going on increasing to switch off the water heater. Okay, as like that we categorize the voltage sources to switch on or switch off the process. Okay, similarly if you come into this is for switch on or switch off the heater. If you come into the wall, the same process, instead of the controller to on off the walls, we are using the variable sources. Okay, here also what a variable control valve with increase or decrease the water flow to tank proportional input. I want to close the valve to 60%. Yes, it's possible. It's possible. But if you go into discrete process, you can do the with us. We can open or close the valve, but you cannot able to go for partially open or partially closed. But it's possible. Okay, that's the continuous process. Okay, so further what happens? You have to fix the variable voltage. As is 0 to 2 open, 2 to 3 partially open or partially closed, then 3 to 5 it's fully closed. Okay, as like that. Here we can fix some limits. Okay, with respect to voltage, and we can control the process. That's why we are saying that's a continuous process. If going to the discrete process, we are having only the either on off on or off command. So what happens? We are not having any intermediate process also to control systems. Okay, so to partially shut down or partially close the valve, it's not possible in the discrete process control, but it's possible in the continuous control with respect to the variable voltage source. If you come into the closed loop controller, the same example. Okay, here we are not seeing any sequence control controller. Okay, so in the same example, it's a closed loop control system. Okay, so what happens? So variable voltage source signal is given to the water heater, and if the temperature is reached, what happens is signal goes as a feedback signal and goes to the set point and compares the set point and the output what's coming from the system and find out deviation is there. If any deviation is not there, what happens? Yes, it switch off the water. If any deviation is there, to overheated or not heated means depending upon that it gives a power with respect to variable voltage and this water in the water is going to be heated. Okay, the same process in the valves. Okay, if the valve is open, the water is flowing in the water heater, and if the level of the water is reached to a certain level and gives signal to the desired point, it starts to compare the desired point and the output. And if any deviation is there, deviation is there means what happens? The water heater, the controller gives a signal to open the valve. Again, the water is filled in the water tank. Okay. Until once the level is reached means what happens? The water in the pedal in the power the signal means water to water heater. That means the valve. Okay, the valve. Okay, the valve is shut down means water in the water is going to be water in the water not going to be flowed and it's maintained. Okay, so here water it as a process and the variable voltage source. That means variable voltage source to the water heater for the heating coil and variable voltage source for control valve as the controllers. Okay, so the actual temperature and the level are continuously monitored and compared with the desired values to eliminate the deviations. Okay. So this if the deviations are there, what I said, depending upon the deviations, we have to increase or decrease the uh, here the source for the heating coil. That means power to the heating coil, or here we have increase or decreases the water input to the tank with respect to the valves. Okay. So with respect to the deviations, we have to control we have to increase or decreases the power to the water heater. That means heating coil in the heater. Here are to be open or closed down, or open or closed, or partially open or partially closed. Okay, of the valves in the tank with respect to reference values. Okay. Sir, what's the difference between the discrete control and the continuous control closed loop process? If you're going to discrete control closed loop process, then that same thing on off breaker is there. We are having the production of interlocks. That's a sequential process. Okay. So we're coming to here, the same closed loop control. Here what happens with respect to variable voltage. So is we can able to control with respect to the increase of the voltage, the decrease of the voltage, we can able control the system with respect to the outputs what you're getting from the process. Okay. So that's advantage of the closed loop control. So most of the industries are preferring. In conventional days, which industries are followed either on-off controller. On-off control means we are having only two modes, whether on-off mode. Okay. But if we come into closed controller, what happens with respect to voltage? With respect to voltage source, we can fix the limits and we can switch on or off the systems, and we can also fix the limits of this. We can fix the limits for the process. Okay. That's possible in the closed loop control. For example, what I said previously, discrete control means it's relay technology. What I said here, we can able to find out the relay technology, normally open contact, normally closed contact. Okay, so we are having a coil, electromagnetic coil. So what happens if you supply the power source? If you supply the power source, what happens? The magnet is going to be energized. Once the magnet is going to be energized, what happens? Once the magnet is going to be this coil is energized, what happens? It pulls this lever to the side and it's closely. Normally open contact, it will be closed like this. Once if you cut out the power supply to the magnetic coil, what happens? It will opens like this. Okay. See, whether it's normally open or normally closed. That's all. It gives signal. Once it reaches the temperature, it gives signal. What happens? Once it reaches temperature, it gives signal and it cut off. The power supply will cut off and the system is going to be stopped. Once the system is not reaches the limit, what happens? If you want to switch on the system, gives signal to the magnetic coil, it's energized and it attracts this towards the side, and once it attracts, once this contact touches with this contact, it's going to be closed. The system is going to be starting condition. System going to be working condition. Okay, so In discrete control, this is a relay technology what we followed in the conventional days. We're coming to solid state technology. So here what happens? Relay technology is partially replaced by the solid state technology. The solid state technology is NAND gate, NOR gate, and XOR gate. We are proposing gate systems to control the process. Okay, to control the process. So here what happens? We have normally open delay, normally closed delay, normally open delay, closed delay. Okay, two normally open or closed delays. Okay. Either on or switch, either on or off. Okay. So similarly, what happens here? So it's a AND gate, okay, and we are proposing NAND nor XOR gates to control the process. Okay. So this is NOT gate, this is AND gate, and this is OR gate to control the process. Also, apart from that, we also in solid technology we are proposing the operation amplifiers also to control the process. Nowadays, what happens? We are proposing the thyristor as a continuous process. Okay, so since it's going for variable voltage sources in the continuous process, we are proposing thyristors. We are not proposing any operation amplifiers, relay-based systems, and the solid-state-based systems. Okay, what the technology is saying that initially they use the relay-based system. Slowly they're coming to solid-state technology with respect to gates, and after that it comes to operation amplifiers. And now we are having a thyristor-based controllers. That means instead of the on-off controllers, we are having thyristor-based controllers with respect to variable voltages. We can control the systems. Coming next slide, transition of the hardware control to software control. Okay, what I said here, in the previous conventional days we are using the relay or solid state based automation strategy hardware controller. Nowadays we are using software control, the processor with respect to memories. Okay, so this is a microprocessor or advanced processor embedded processor systems. With respect to the automation strategy, we are using the software based systems. This is hardwired and this is software based system. The control systems itself in the olden days were categorized into hardwired control system and software control system. Nowadays the technology is focusing on the software control systems. Okay. So what is the merits of the software control system? Means it's a more compact, it's more power efficient, and probably what happens is going reliable, flexible, communicable, and self-supervisable. Okay, and it's easy programmable. So if any program is happened, you can erase the program, you can go for reprogram, but it's not possible. Okay, and probably if you're going for relay, we have to use a 230 volt AC current. So here that's AC is not needed. Okay, so only saying that it's more compact and power efficient. Okay, we can able to minimize the power also, and the process also speed is too high. If you go and increase the memories, okay, and it's a self-acting system, that is self-supervised system. Okay, if you feed the program the memory, and the memory, if what are the outputs coming from system, okay, the outputs compared to the defined inputs what you feed in the memory, it start to check whether it's happening, whether any deviation is there or not. If any deviation is there or not, depending upon the deviations, it start to control the or initializes the process. If we come into the information structure in the controllers, as I already said, the human interface system, instrumentation system, process. This is a controller subsystems. Okay. Controller subsystems. What happens from the instrumentation subsystems? The inputs, process inputs, the input from the process, and that's called as data system. Data is what occurred from the process through the instrumentation subsystem. It transferred to the controller. Okay, so what happens? So we already programmed in the memory. Whatever the process inputs, we got it from the process through subsystem system. It transfers to controller, and controller start to check the process inputs what you get it from here with the defined inputs with the defined program what you already fed it. Okay. And depending upon that, it starts to control the process also. And probably what happens, what's the process happening, it gives a signal to the interface systems. So what it's saying, with the instrument systems, transferring the data to the controller, and controller starts to control the process, starts to work with the process, with the data. Okay, and anything goes beyond the limits, the controller itself immediately starts to control the process through the command outputs. In meantime, okay, through the process through the instrumentation system. In the meantime, what happens? What the process happening? It transfers the signal to the human interface system. Okay, and the human interface system is also having the right to transfer inputs from here. And what happens? The inputs will be processed here, and inputs will be taken care to the process as output from the input from the controller to the instrumentation systems. Okay. So what happens? The controller acts on both the sides, the respective human control systems and instrumentation systems. It takes the data and processes the data and goes beyond the limit or not. If it goes beyond the limits, the controller starts to control the process this side immediately through the command outputs. Meantime, gives signal to human control systems, and human control systems finds anything is going beyond the limit. And what else? If human control systems also operates the transfer signal from that side to the controller, and control taking the signal to the process through the command outputs to the instrumentation systems. So if you come into the next category, controller structure. So what a detailed control structure here. What happens? This detailed control structure is categorized here, and the controller is there. Okay, here there are three categories of subsystems are there. One is power supply subsystem, one is processor subsystem, and another is IO subsystem. IO subsystem, this is IO subsystem, and this is a processor subsystem, and this is a power subsystem. The power system is taking care of the power supply module for the both the processor and the IO systems. The processor systems taking care of the processor and memory modules. Okay, processor and memory modules. So what are the data you're giving as a what are data you're given as a program in the memory? That's called as keep it in the processor system. Okay, and input output subsystems, IO subsystems. Okay, so in the input output system is integrated with the process. Okay, so what happens? The inputs or outputs or depend upon the analog input digital outputs from the process. It transfers taking the data from here and transfers data to memory. Okay, the memory already having the backup, defined program there. And the defined memory processor start to taken the defined program with the observed input, okay, observed in digital inputs, analog inputs, and check the process whether it's happening properly or not. If not, means okay, so the process again gives signal to the instrumentation process through the digital outputs and analog outputs and pulse outputs. Okay, so what happens here? We having the processor, power supply, and the IO systems. IO systems debited for to transfer the data from the input and output signals from the processor from the instrumentation system to the processor system. Okay, so for this processor system and in IO modules we need power, so that is taken care by the external power source. Okay, so already you made a program in the memory. Okay, so let's keep it in the memory. The processor takes the program to the memory depending upon the input signal what he got it from the process, subsystem systems. Okay, from the digital inputs, analog inputs, and pulse inputs, and start to check the process whether the process is happening properly or not. The process happening properly, not properly. The process not happening properly. Again, gives a signal. There's a command outputs from the processor to the digital to the system through digital outputs, analog outputs, and pulse outputs. This is a control structure, detailed control structure of the controller subsystem. Okay. So coming to the next category, discrete control. Here sequence control with interlocks. So what happens? Discrete control, sequence control interlocks. We are having two categories between controller and the instrumentation interface, between the controller and the human interface. Okay. So if you take the between control and the instrumentation systems, between control and instrumentation systems, we are having some discrete instrumentation devices. If you come into this side, between controller and the human interface, we are having uh, some discrete components. That's human interface systems. Okay. If we come to this side, we can find the level SR switch, level supervision relay, and temperature supervision relay. Okay, and VCR. That means valve control. We are having level sensor, temperature sensor, valve sensor. Okay, we are having three relays: level sensor relay, temperature sensor relay, valve control relay. If we come into this side, VSR, valve supervision. You have to find out whether the valve is properly working or not. Valve supervision relay. That means to switch on or switch off the valve. Okay. Switch on or switch off the valve. Valve supervision relay, and VCR is a breaker circuit. That means to close or open the breakers, and BSR is a breaker supervision relay. Breaker supervision relay. That means having level sensor relay, temperature sensor relay, and valve control relay. Okay. To monitor these three things, we are proposing the brake controller relay and the valve supervision relay. Okay. So these are the instrumentation devices. These are the discrete instrumentation devices what we propose between the instrumentation process and the controllers. If we come into this side, between the control and the human interface, we have some components. Human interface components. We can say that the human interface panel components or human interface components. It indicates what's happening in the process for the human operators. it says LSD, level status indication lamp, level status indication lamp, temperature status lamp, then very well valve control switch lamp, valve control switch status. Okay. And finally, if coming to valve suppression status, VSD, valve status indication lamp, and BCS, brake control switch indication lamp, and breaker suppression lamp, breaker status indication lamp. Okay. So this is the circuits. Sequential, for example, if you get discrete, I am saying the discrete control, sequence control is not a continuous process. What I am saying that it's discrete means it's on off controller. Okay, so on or off control, on or off control, on off control. Let's take a delay, on or off relay, on off relay, all on off relay. Okay, so on off relay. What I am saying that here, so we are having three sensors: level sensor, sensor, and valve control relay. Okay, so for these three sensors, okay, we are proposing the valve controller switch, brake control switch, and valve suppression, brake suppression relay. Okay, so these are three processes to monitor the what's happening in the water rate automation. This, we are proposing the relays. We are proposing the relays on off controllers between the instrumentation control systems. This is a discrete controller. I am saying that discrete controller, discrete instrumentation devices, what we propose between the controller and the instrumentation process. The controller and the instrumentation process. Here, controller and the interface systems. Okay, instrumentation subsystem and control system, and the control subsystem and the interface system. Controller plays both the side. Okay, IO devices that acquire the data from the processor and transfer data to controller, and similarly it shows what's happening there with respect to the indication status in the right side. Okay, same interface systems. Okay, here you can able to find level status indication, temperature status indication, valve control indication, valve status indication, brake control indication, brake status indication. Okay, this is either on or off, either on or off, either on or off. It indicates light on or off. On means okay, off means going something on. Okay, we have to understand like that. We have to diagnose like that from the human interface systems. If you come into next slide, discrete process automation. Control, it's a control structure. Okay, so what happens? The same structure. Okay, so what I said here, same thing. Okay, the same thing. The same thing here. Same process. Okay, so we are in the power supply, process of systems, and the IO systems. Okay, so what happens between the process and instrumentation? So here what happens? You can able to find out the controller and the water heater, controller and the human systems. It takes the data from here. It takes the data from here, from the water heater to the instrumentation subsystems, and transfers the data to memory. Already pre-programmed in the memory. Depending upon conditions, the already pre-programmed. The process takes the pre-programmed data in the memory with the observed data from the instrumentation process, and it's okay, not a problem. If it's not okay, it transfers the data to the digital outputs to control the system, and parallelly it transfers the data, same data, to this human systems through this devices. This is the instrumentation subsystem. This is the devices to analyze the status of the process. Okay. Once again, I'm saying that from the water heater system, it transfers to the IO modules taken care to transfer the data from the water heater system through the instrumentation subsystem. Okay, and goes to the memory process and goes to the processor system. The processor system already made a program the pre-programmed in the memory. Okay, the memory starts to compare the observed observed conditions from the water heater with the predefined condition, and if it's okay, it gives signal to the interface systems. Okay, if it is not okay, what happens? Memory starts to control the process through the digital IOs. Okay, and parallelly also transfers the data to the human interface systems. Indicates the process happened properly or not. Even though the process within the limit or not, it transfers the data to the inventory system to indicate the status of the each and every systems. Okay. Apart from that, if anything goes wrong, it's observed by the processor. The processor triggers the digital IOs to transfer signal, command signal, a controlled signal to control this process. Okay. Similarly, the control signal is also transferred to the operator panel. That's a unit transfer to the unit systems, and it indicates this process going on. Okay, so what happens, this IO module is shared between the both the sides. That means both the instrumentation process and the operator panel. If you take instrumentation panel, it transfers the data. Instrument panel is acting as a mediator to transfer the data from the process to the processor with the help of the DIO, digital IO. Okay. Immediately, if anything happens beyond the limit, the processor, whatever command signal is given by the processor, the digital output is taken signal from the processor and transferred to the process through instrumentation systems. Similarly, what are the process happening here? Okay, it transferred to the inventory systems to monitor the process happen properly, not from the operator side. Okay, so this is already all the things what I said. Discrete automation, discrete process automation means it's a on-off controller. Okay, so this, what is the problem means what I said is it takes some more time, and probably we cannot able, if we're not having variable voltage source, we cannot able to control the process with respect to the limits. Okay, so only are going for the uh, continuous process. Okay. If you coming to the discrete process automation control, if a small example, what I said is that we are having a DIO, digital inputs and outputs. Okay, so here what happened, pin indicates it's output channel. So we are having, generally if you take the DAC cards, we are having, it's a DAC card. You can see the DAC cards. Generally we are having the input signal is around 20 and output signal is around 20. Okay, IO channels. Okay, first 10 channel indicates first. We can say 20 channels. In 20 channels, 10 channels is for inputs and remaining 10 channels for outputs. In the 10 channels, we can say that 1 to 2 debit for temperature, 2 to 5 debit for water, 3 to debit for wall level. As like that, we have the right to split up the channels with respect to your application. Okay, so that's the thing. Here we say that the same thing. We say that D10 to 11, D10 to 12, level sensor, temperature sensor, and wall sensors to indicate the level status, temperature status, wall status. It's D10, 11, 12 taking care of the to monitor the level, temperature, and the wall status from the process side. Two subsystems. Okay, from the process side. Okay, if we come into next category from the operator panel. Okay, to find out what's up for the operator panel. From the operator panel, find out what's the breaker status, what's the condition of the breaker, what's whether the valve is open or not, whether the valve is closed or not. Okay, whether the breaker is open or not, whether the breaker is closed or not. Okay, so this is to the operator panel. Okay, from the operator panel you have to check it whether the valve is open or not, whether the breaker, that means for to energize the heating coil in the water heater, it's opened or it's energized or de-energized. As like that we have to check the process. Okay, for that we debited D13 to 17 for this process. If you come into outputs, okay, so level status indication, temperature status indication, wall status indication. Okay, that indicates D was digital output 0 to 2. Remaining channels debited for the remaining process. As like that, we have to categorize the input module and output module with respect to the respect to IO channels. Okay, so 10 I in of, for example, you have 10 IO channels, 2 channels debited for several purpose, 2 channels debited for several purpose. Here, what happens? 3 channels debited for process, the remaining channel debited for operator panels. If you come into here, okay, the digital output. First three indicates to operator panel. That means data transferred to the operator. And the taken care by the DJ output 0 to 3 third pin. Remaining the 4 to 7 pin taken care the signal, what signal taken transferred to the process. Okay, that's taken care by this digital IO models DO4 to 7. Okay, so coming to continuous control. So far we've seen the discrete control. Am I correct? So coming to continuous controller, the processing is different. Okay, so we can able to find out so many relays are there. For example, these are relays. So many relays are there to monitor the process. Okay, since it's a level sensor, temperature sensor, VCR sensor, value control, valve control A. For this to monitor these three processes, we have to debit around 7 or 8 relays to monitor what's the process happening or not. Okay, but if you come into continuous process, we are not having such much of relays, such much of thing. It can with respect to variable voltage, we can able to control the process. Okay, so what happens here? LT, water level transmitter, and water temperature. It's a level sensor, temperature sensor, variable control valve, and variable voltage. I think so. Variable voltage drive is also not needed. Since valve is there, we are going for variable voltage drive. So try to avoid this variable voltage drive. Only 3 devices. Instead of we are proposing 3 plus 3 6 relays, we are proposing only uh, level temperature, level transmitter, level sensor, temperature sensor, and the variable controller. Okay. So with respect to variable voltage, 0 to 2 volt indicates the level is the temperature is on. Okay, that means we want to switch on the breaker, and probably the heating oil in the element is going to be heated. Okay, If not, if the temperature is rigid means yes, it can get by the 3 to 5 voltage. As like that, we can able to control the variable voltage source. With the variable voltage is taken care to control this process. Okay, the control process needs only continuous inputs and outputs to support both open loop and closed control. Okay, so here you not have the ability any relays to switch on or off the systems. We are proposing a continuous controller and to monitor to control the process. Okay. So the hardware configuration is same as a controller, but what happens here, we are having less number of pins instead of having one number of, if you take the same process, we are having 6 pins. Okay, to taking the 6 layers to taking 6 pins, that means digital 6 digital input modules taking care of the 6 process. Okay, but here what happens, we are having only 3 process and we are having only 6 pins. We can have to debit only 3 pins taking care of this pins. That means less number of channels are going to be occurred for this pins. Okay. So if you come into water heating process, we have instrument systems there and water heating process, the control is there. Okay. So the signal transfer from the water heating process to the control through instrument systems, and we are having only 3 signals. If we come into here, what happens? The same. What other thing is happening? The same thing is going to be indicated into the operator panel for the humans. Okay. So less number of inputs and less number of IOs, less number of inputs and less number of IOs. That's the thing I was saying. Okay. Okay. Because last time what you're going to see in the control process automation structure, the same thing is there, same order structure is there, but if you're going to here, more number of IO channels should be needed. That's what it says. More number of input modules around 3 plus 6 8 channels needed, 8 modules needed. Here what happens, same 8 modules are needed, but if you come into here, only limited modules. Okay, only limited modules. Okay, the same structure is there, since the variable voltage source is a continuous process. Okay, what happens, the input parameter, the input systems are, okay, the instrument systems are minimized. Here the operator panels are minimized. So what happens, it's analog inputs. Okay, going to step what's the digital outputs, inputs are there, but if you come into continuous process, only analog inputs or outputs. But what happens, the IO modules are very less when comparing to the discrete process. Okay, so we need 8 digital inputs and 8 digital output modules, but yeah, instead of 8 we having either only 4. Okay, so if we go into the continuous process, okay, what happens, since analog inputs and analog outputs, okay, it's in the IO channel is whatever IO channels needed, input output DAC cards, we assign the DAC cards. Okay, we can take the minimum IO channel DAC cards and we can control the process. Okay, and finally, if you take the continuous process, since a variable voltage source, we can continue the process with respect to our thing, with respect to our requirements. Okay, so we have fixed the limits and we control the process instead of going for on-off controllers. If you go into on-off controllers, we have only 2 modes, on or off. Here it's not like that. Let's put the voltage source. We can fix the limits to switch on or off the systems. Okay, this is the advantage of the continuous process automation control structure. Okay, thank you.